Good morning to all of you. Last night I spoke to my daughter for probably the nth time, I would say, because she wasn't well the whole day. So as a mother, I was a little worried. So I was calling her up. Everything okay? Anything you want to say? I started from the morning where she talked for a long time. She said, "This I coughed at night. I took this medicine. Blah blah blah." The late night call just before going to sleep, she said, "How many times are you going to call me up? I just have nothing to say." All right, so I think I have reached that stage. Yesterday there was so much discussion, and almost all the things that I wanted to cover has been covered. So I have nothing to say, but still I'm going to speak for half an hour. That is one. There's another point which I thought, I've been thinking about it for some time. When I joined the corporate world after 25 years of my academic experience, everyone asked me, why did you do it and how do you see the difference? And I felt there was no difference. Everyone, the same human beings, everything is same. But I think today I was reflecting on this today morning, I can tell you what is one difference that I say. Every time I would go to a conference when I was in the academic world, I was waiting to say all the research that I had done, all right, and how things. Now, I have to think 10 times because all these concept of IP and, intellectual property right, all that comes in. And I really, I'm sure it's not just Cummins, it's every company. So we think 10 times before what we want to put across to an audience like this. All right, and that's the difference. That's a very very big difference. I feel, especially for a person like me who just loves to talk. All right, I just want to give ideas. I just want to speak a lot, and then suddenly you feel, but that's something which I accept, and I'm going to move forward. And I made a background now to tell you that you have heard most of what I'm going to speak. Nevertheless, I'm going to give you a slightly different perspective of the whole thing. So I'm going to be talking on strategies for lower emission and fuel consumption on heavy duty vehicles. But there is, towards the end, initially I'll try to just say what you all know. In fact, some of the slides have also been shown earlier. But after that, I'm going to tell you something which I want to from the bottom of my heart, on to see if we really want to achieve something in this country. There is some more things to do. Right. So this is, of course, I'm just going to take you through the emission roadmap and talk about some key requirements, which is not just technical but non-technical also, and balance between the emissions, global architectures, some solutions which we want to think in an integrated manner, and a slide which all of us know, just to show you that in 2016, today, this is where we are. In 2021, this is where we are going to be, where India and China are also going to follow the BS6 or equivalent. In fact, I would say Euro 6 or equivalent. Right. India to implement BS6 by 2020, and the fuel economy norms, which are now being discussed very, very seriously, are intended phase 1 to be applicable from 2018. And that's in discussion. It's going back and forth. It will take some time because we want to achieve quite a bit. We know we have already stressed our industries. We are all stressed because BS6 is coming in after skipping BS5. There's a lot of development work happening. So having said this, what really makes up for the Euro 6 legislation is something which we all know. We can start with world harmonized test cycles, the challenging emissions, which, the graph I'll show you, and you've seen it before. The repair and maintenance information, of course, is not a part of the GSR which has come out, but it will definitely be there in the AS137 or the procedures. And then we have, of course, the onboard diagnostics, the NOx control monitoring, and all what has been, which we will also have enough time to learn from the Euro 6 and the USA. This is a graph which was shown just before. I think you showed that, but all intended to show you just that we have an addition of a particle count limit. Now it's an important reflection on, it's not just the, it's not just um, the size, the amount, but the number. Okay, the just not the mass, but the number in different sizes, which is very important, and more so because that's going to govern. Okay, it's important to keep that in mind because that's going to govern the strategies which we are going to use to, remove them. Coming to this. So now comes, what is it that we are looking for? We know all this. We now have our regulations. So what is it that we are looking into? So we need a higher fluid economy. I'm saying fluid because almost it's become like a second part, just like saying combustion is going to take place in an engine. Everyone talks about SCR, everyone talks about catalyst. We are almost sure that without a catalyst and without the EGR, we cannot achieve it. So it's become a part of the technology now. So if I have to say that, then I think higher fluid economy to drive the fleet owner's profitability, of course keeping in mind the consumption, and that would be a major buying criteria. Then comes the reliability, which is equally important because it's not just the question of that we need, it needs to be reliable. The fact is that even if something breaks down, are we ready for good service? We aren't, because that's again another industry, parallel industry, which has to develop. As much as we are developing the OBD, and we have all regulations and norms to meet, but if something goes wrong, it's not easy as a mechanic just coming, opening your engine and setting it right. There is a lot more to it now, and we have a whole second industry of training and these service people. I think it's another parallel thing which we need to do now, and if we don't start it now, we are going to end up in a problem. Then we have the competitive product pricing, of course, durability, that's our beaten improvement, synchronized service intervals, because now again we have many more things. We have the oil drain, the PDF, ash cleaning, so everything has to be synchronized. And then compliance to the OBD requirements, of course, minimum cost, least cost. Having said this, okay, just like I said, we sort of all know what the engines and what the vehicle is going to uh, have. So I'm looking at the engine part. It has to be, we will start with combustion. I think Dr. Marathe spoke about it yesterday in the morning. We have to really look at the combustion, which we can't avoid. How much ever we may say we have advanced, but I think there is a lot of work to do there. We need to have a good air handling system and or EGR. I have written and here, but I would say and or EGR out here. We need to have very good after treatment systems. We need to have electronic controls. We need to have good fuel systems to enable us achieve what we want to achieve for this combustion. So they are all interrelated. We need all the technologies to be developed simultaneously. Now, why I say this with so much emphasis is that we have very less time. We really have very less time. Okay, 2020 is just round the corner. And for that, if I need, the option is yes, maybe the principles have developed, or we do have in the US, Europe, and other places where some technologies have been developed. We have to, at this point of time, unless there are some companies who are already ready with it and in anticipation, which probably are very, very less in this country because we don't have the culture of putting in money on research as much as it is there outside. Having said this, so it has to be an integrated approach. Okay, it's all about technology integration at this point of time. Okay, again, just to re-emphasize on the way it has, the evolution has taken place, depending on the type of the fuel that we are moving to. So we started with aftercooling, then the electronic systems, then EGR, then particulate matter, SCR, and then we slowly now already started talking about waste heat recovery, because we are also looking at the fuel economy, and then telematics and all. Telematics and others are things which are also, it's not just data processing, it's just not connecting, it is also a lot of safety, it is a lot of maintenance that we talked about. So there is more connectivity required. Okay. Having said this, so the future is now not just the emissions. When we say emissions, the criteria pollutants, but also CO2. So when we say low strategy emissions, emissions are all that we are emitting. Remember, there is one more gas which we don't talk about, and we will probably not talk about for years, but very soon we might want to talk about it, and that is the moisture, the water that we are letting out. I can talk about it for a long time, but I'm going to leave it at that. So we are not considering H2O at this point as an emittant. We are saying CO2, and we are talking about the criteria pollutants. And then came, of course, the downsizing and downspeeding. Again, to take care of the driving conditions here, I would say the road conditions, the infrastructure conditions in India, and also keeping in mind that now the integration with the powertrain also has to come in. So, what are the global architecture paths that we can generalize it into? So we can talk about no EGR, EGR, SCR is there. All right. I want to say this again and again because I'm going to talk about it later. All right. So here, I think all of us know this. We don't have to really worry about it. But then, okay, this is the exhaust. And then we have a DOC. We have sensors in between. We have a DPF. Then we have something to ensure that the SCR works. So we have a catalyst. We have ammonia generation. We have whatever is the balance ammonia. We try to remove that, and that's how it goes. If I have an EGR, I have something in between here. I have an EGR cooler, and I make use of this. So that decreases the load on the SCR. I just thought this table might be a little helpful, quickly to go through. I must also tell you that I really speak and go very fast on my slides. So the no EGR says, okay, the SCR size, the technology, the controller integration are very critical because they could be big. I don't have any support emission strategy. Increased DF consumption, obviously, because this is unsupported by AGR. The OBD becomes challenging depending on, especially in Indian conditions, which we have discussed a lot yesterday, because of the low speed and high load conditions. And then I have the PM, which provides an avenue for my, what do you call that? Your precious metals drifting. Then I have the PM control, which becomes challenging. But if I have an AGR system, it's not any less. All right, I have different set of problems. I have relatively, of course, less demand on the SCR, and the optimization is, basically I can do a size optimization, and I have a low DF consumption. For the particulate matter, it's just vice versa. I need a DOC optimization, so that's an additional development work there. And I have increased regeneration frequency because my particulate matter will now go up, etc. Having said this, so what's the other thing which is influencing? It's our duty cycle. Okay, so it isn't anymore just one point. It's a lot of it's not just single point. It's not just BSFC. And it isn't at a point, it's a duty cycle. Now, I think one of the very challenging questions in India is, do we know the duty cycle? Okay, we would say yes, but my fear is we probably don't know how the infrastructure is going to change. And we do know that we are going to go into higher speeds. Average speeds would be higher, because I see the in corridors coming up, we see the the lot of funding being pumped into the infrastructure. So we do see that, but still, looking at the rate at which the vehicles are going, looking at the rate at which the population is growing, looking at the rate at which the infrastructure is growing. And I think I think we need, and then looking at the uncertainties which we have seen all these years. I know this government is doing in a different way, but knowing that there is an uncertainty, I think it will be a $1 billion thing to just predict the duty cycle which will be there in 2020 and onwards. It's not the question of just 20, because there's a lot of conformity which is required, and there would be a lot of changes in the infrastructure. So I think that's something where a lot of work needs to be done with our testing agencies, where we really need to work on what could be the predictive, especially for the predictive duty cycles. I think a lot of predictive modeling is required in this case. Having said this, now let me come to, I'm going to just name, because it's not going to be very effective if I start describing all of them, but separately if you want, on an academic level I can talk about it. But I'm just trying to list out some of these important technologies which you need to work on. And starting from, so I'm going through that, cycle. So advanced combustion and fuel systems. It's very important that we, again, I think yesterday, it was Dr. Marathi who spoke about HCCI and different low temperature combustion. Yes, we have to have a mixed mode of combustion. A lot of work needs to be done on that. Early PCCI, maybe, across the torque and the speed levels, we need different types of combustion. We also need to have fuel systems which will have higher injection pressures. If I want to support good combustion, then I need a lot of work to be done on the fuel injectors. Then I need a cool EGR, flexible air handling system, which I'll talk about, and the, whatever is required to ensure that my combustion is good. In the after treatment integration, so we need to optimize it for performance, reliability, and cost. And for example, we have all this now, air intake system along with a good combustion, good lubricants. Someone asked me yesterday this, good oil, with all that as the input and the air intake, we have good turbos, we have good combustion here. And then I have modular exhaust treatment systems which have to be integrated to the whole thing. For the efficient handling system, I can talk about dual stage turbocharging, I can talk about variable geometry turbine. All the technologies are available. What needs to be done is integration, but above all, what needs to be done is low cost. I think if we need to survive here, okay, low cost, frugal, yet sophisticated. The problem is, when we say frugal, it is mistaken with the word jugaad. Okay, it should not be. Let's be very clear about it. Let's be very clear that frugal or innovation does not mean jugaad. For those who do not know the meaning of jugaad, I must tell you that it's already found a place in the dictionary. Okay, that word has found a place in the dictionary. Jugaad is a word which I would be happy to translate it to frugal or innovation, but the connotation is that it's something where we do a stopgap arrangement. If there's someone who can help me define this for people who do not know what is jugaad, I'll be very happy. But I think it's something like, again, the word is chalega, in it's okay. You just do something to make it work, and it might not be a reliable solution. That's what they say, but actually many of them are very reliable, and it's not sophisticated. I think that's the best that I can explain the word jugaad. If there is someone who can help me explain it better, but I'm sure those who know it, I can see smiles on their face, because we all know, and we are all scared that we should not do jugaad in the name of frugal or innovation. We should be very, very careful. I think that's a warning and a caution that I'm giving. We had to be very careful on that. And believe me, however, we are capable of doing that, okay, because we have brilliant minds here. So if you try to bring in systems which people can't touch, then there will be bound to have jugaad here. If we do not take care of good service and maintenance capability and accessibility, then we will end up seeing this at some point somewhere. Okay, of course, the friction reduction which I talked about, we have talked about pistons, rings, bearings. So it almost looks like you touch every component of the engine. Okay, you touch every component of the engine. I'm not even talking about the vehicle. I'm talking about the engine and the powertrain. Waste heat recovery is again a very interesting thing. It's the amount of, it's the gain that we get and the cost. There is trade-off is the key to this particular word, I would say. And not just that, maybe the maximum efficiency gain would be through a, simply using an organic Rankine cycle. But do we need that in India? Okay, do we need that in India? Do I need to air condition my driver's cabin? No. So I think it's very important that we know the technology is available, but the application of that technology to the Indian context is very, very important. The powertrain optimization, of course. Again, I think downsizing and downspeeding is some things which we need to be carefully working on. I say carefully again because we need to know where our capacity and our power ranges are going to. I'm going to skip this. All right. Having said this, the other is, of course, reducing CO2. We have to keep that in mind. And that means, the reduction in idle, low net carbon fuels, hybrids, low temperature treatment, all of it put together. Okay. And alternate fuels. Now let me tell you what is the key thing that I want to say. There is a lot of development this is my perspective, a lot of development which has happened, and because this time is very short, we are all looking into the technologies which has already been developed. We are so we are so confident that SCR is required. We are so confident that EGR may be required. We know these are the type of turbines. But I think this is the time, maybe 2020 we cannot avoid getting ready. This is the time to look for innovation. This is the time to look for innovation. And, I think it was, I don't know whose quote it was. If you want to reach somewhere early, then if you want to walk fast, okay, you want to reach somewhere, then you need to walk fast alone. But if you need to do some quality work and achieve something, some goal, then you need to walk as a team. Okay, Ratan Tata said that, right? I agree. So that is something which is always, I think this is the time when we need to collaborate. When I say we need to collaborate, I know all the companies will, no, we'll all work to, we are competitive, all that is fine. But still, I think there is some amount of collaboration with a lot of support from the government and using our resources. We have no brain drain today. We have reduced the brain drain to near zero. So it means all that brain is available, the resources are available in the universities. Believe me, I say this because I have seen both the sides. This is the time for industries to make use of all the resources in the country, work on a parallel industry, two parallel industries, one for the service and maintenance and two for innovation. Okay, this is the time when we need to really get a lot of support from the government. The industries also, I'm saying is it's not just the industry putting in money. I think there is a lot of consortium efforts which need to be taken. I say this because Catalyst, okay, SCR, we already know the problems, right? We are already saying what is it going to do at the lower, temperature exhaust. We know a lot of problems, and we have to look for innovative solutions which are very specific to India. And for all you know, it will be re-innovation. It will be reverse innovation. I'm sorry, not reverse innovation. We should be able to find an export market. I feel very strongly that low emission strategies, what we know is all that I have put here. But what we don't know is what we have to work on. And there are a lot of, I see a lot of papers which are coming up on different type of technologies. We need to pick them up and we need to start working on it. And whoever is able to do it will be the winner, believe me. And I think this is a time when, all these music programs which come in the on TV, uh, Dance India, Music India, Saregama, all those things. I think we should now start having innovation for design and innovation contests like this, open contests. Anyway, jokes apart, I think that's all that I have to say. That these are traditional strategies, conventional. We know we have to go through it. We know we don't have time. We know we have to work within this, and therefore there has to be parallel approach, which is absolutely necessary if we need to survive, and if we need to do what the government wants us to do, that is to meet the norms. Thank you so much.
Thank you, Anuradha ji. Yeah, she just finished in time, so we can have maybe 2 questions. Anyone asking? Yeah, please.
Dr. Ganesh, thank you for the excellent presentation. Just a question about your comment. Sorry if you can't see me behind the light. So you had a slide where you showed downspeeding and downsizing as being a potential approach. And I'm just curious, given that engine sizes in India are much smaller compared to other markets, what do you see as some of the opportunities or challenges around the applicability of downsizing and downspeeding for the Indian market? Thank you.
I couldn't see you, but I presume you are Ben, because I
Yeah,
could hear
he's,
you.
he's
This is. So I look at it this way. I say that because there would be a change. There would be a change in the size of the engines. Okay, that should be, if we have to. That's what I said. It's all very interrelated. We have to have a predictive analysis to see what would be our average speeds and how would be our driving cycles. Having said that, if we are going to cater to that, we may want to look at the other options also. Keep both the options together. That's what I mean. Because I don't believe that we will be able to survive with the size of the engines which we have.
Can I add, Ben, on downsizing? The type of engine sizes which we have will certainly fall into definition of downsizing, but we do not have the type of turbocharging and other associated factors which get in to make it a more powerful engine and more fuel efficient engine. That is where we have to. Another question here. Yeah, please.
Dr. Ganesh, you spoke about the use of the pros and cons of EGR and no EGR. Which route do you think will be the most